Let us take the next heading, which is called as inversion of mechanism. Now, what is the meaning of inversion? I'll write here. If one link of a kinematic chain is fixed, then it is called as a mechanism. We have seen that in case of kinematic chain, the links, they are not fixed. But if we are fixing any one link, then it is called as a mechanism. Next, the process of fixing different links one at a time to get different mechanisms is called inversion of mechanism. Now, as we can see here, if we have a kinematic chain and we are fixing one of the link of the kinematic chain, then it is called as mechanism. And the process of fixing the links one at a time, that is, if we are fixing the first link, then next time we are fixing the second link, then third and fourth link. So when we are fixing different links, we get different mechanisms, and that process of fixing one link at a time to get different mechanisms is called as inversion of mechanism. Next, the types of inversion. The first one is, it is inversion of 4-bar chain. Next, inversion of, we can say, single slider crank chain. And then we have inversion of double slider crank chain. So here we have three kinds of inversion. The first one is called as a 4-bar chain, in which we get different inversions by fixing the different links. Next is single slider crank chain and double slider crank chain. Let us start with 4-bar chain first. 4-bar chain, it consists of 4 turning pairs. That is, in case of 4-bar chain, the sliding pair is absent. Only we have turning members, no sliding members. So I'll give you all the example of 4-bar chain by drawing the diagram for this. Now, here I have drawn the diagram of a 4-bar chain example, in which we have 4 links. I'll give the number. Here we have link 1, this is link 2, link 3 and link 4. Now, as per the definition of inversion, I will keep one link as fixed. Here I'll keep link 1 as fixed. So if we are fixing link number 1 and if I am giving rotation to link 2, then link 2 will move, it will rotate, at the same time it will be rotating link 3 with it, and link 3 will rotate link 4. So if we see in this example, between 1 and 2 we are having turning, between 2 and 3 we are having turning, again between 3 and 4 we are having turning pair, and between 4 and 1 we are having turning pair. So we have 4 turning pairs. Therefore this becomes an example of 4-bar chain, and this example is of rail or you can say locomotive wheels. That is, if we want to drive the wheels of locomotive, there we are having the 4-bar chain mechanism where one of the link is fixed and we are giving rotation to the other links. The similar example we can get in case of bicycle, where we are transferring motion from, we can say, the pedal to the rear wheel, and the distances in between them is fixed, and because of the chain the motion is transmitted. So this is 4-bar chain example of, we can say, locomotive wheel, where we are getting 4 turning pairs. Next, let me give one more example for this, that would be called as a beam engine. I'll draw the diagram for that. This beam engine is also an example of 4-bar chain. Beam engine, and the other name for beam engine is crank and lever mechanism. Here we have the diagram of a beam engine. Now, here as well we have 4 links. I'll call this as link number 1, link 2, link 3 and link 4. Link 1, I'll give it to the cylinder. This is called as the cylinder. So cylinder I am fixing here. Link 1 is fixed, as we can see. Link 2 is called as crank. Link 3 is called as connecting rod. So here, in case of beam engine, which is also called as crank and lever mechanism, we have 4 links, link 1, 2, 3 and 4. The first link, we'll call it as the cylinder. Second is the crank, because we are giving motion to the crank. So it is the first rotating member to which the motion is given. Then we have connecting rod, and next link number 4 is called as the lever. So out of the 4 links, cylinder has been fixed, and then when we are fixing one of the links, we are getting an inversion, and this inversion is called as the beam engine. So as we can see, when the crank rotates, it would be transferring the motion through the connecting rod by this lever mechanism, and then we will get the reciprocating of this piston, and here there would be the gases which are inside the cylinder. So as we can see, when the crank moves down, it would be taking connecting rod with it, and then the lever would move up. Similarly, if the crank is moving up, then in that case what happens, when the crank would be moving up, then this piston would be moving down. So here we can say that with the help of this lever, we can transfer the motion of the crank to the piston. So this is an example of 4-bar chain, where we are getting 4 turning pairs. As we can see, between 1 and 2 there is turning, so it is first turning pair. Second and third, there would be turning pair. Between 3 and 4 it would be turning, and again between 4 and 1 it would be turning pair. So this was regarding 4-bar chain. Now let us go on to the single slider crank chain. So the next heading is inversion of single slider crank chain. In case of single slider crank chain inversion, here we have one sliding pair and we have 3 turning pair. So since we are having one sliding pair, it is called as single slider crank chain. I'll draw the diagram for this. Now, in case of single slider crank chain, here we would be having one sliding pair and three turning pair. As we can see in this diagram, link 1, it is the fixed link. Here I'll say that the fixed link is nothing but the cylinder. Then link 2, it is the crank, link 3, it is connecting rod, and link 4, it is piston. So now when we are fixing one of the link and giving motion to the crank, because crank is the member to which the motion is provided. Now when the crank would be rotating, as the direction I have given here, it is clockwise. So when crank rotates clockwise, the motion is transmitted through the connecting rod and piston would be sliding forward. Next, when it is moving clockwise and it is going back, then in that case the piston will move behind. So piston will reciprocate, that is piston is the slider here, and as we can see between link 1 and link 2 there would be turning, between 2 and 3 there would be turning, between 3 and 4 here also it would be turning, but between 1 and 4 it would be sliding. So we are getting 3 turning pair and 1 sliding pair. So this becomes an example of single slider crank chain, where we can say the piston as the slider. So this was regarding a single slider crank chain. Next, let us see what is double slider crank chain. After single slider crank chain, we are moving on to double slider crank chain. In case of double slider crank chain, here I have the mechanism. The first one, it is called as Scotch yoke mechanism. In Scotch yoke mechanism, I'll first draw the diagram because it is a double slider crank chain. So here we would be having two slider. Now in case of Scotch yoke mechanism, here we would be having two sliding pairs, because it is double slider, so we have two sliding pairs and two turning pairs. Now if we see in this diagram, here we have link 1 which we are fixing. It is, you can say that it is a cylinder. Then link 2 is the crank to which the motion would be provided. Link 3 is the first slider, slider 1, and link 4 is the second slider. So how this mechanism works, that when we are fixing the link 1 and giving motion to link 2, because crank would be rotating. So when this crank rotates, the slider 1, it slides inside this cylinder, and when it is sliding, it would be pushing this piston. So here when we are having such a mechanism and when the crank rotates, the slider slides pushing this piston or towards the right. So here we are getting the sliding of the second piston. So in this case it is very much understood that by the rotation of the crank, when one of the slider it slides, it is pushing the cylinder, it is pushing the piston here into the second cylinder which we have here. So here in this case it is evident that we have two sliding motion and then there is turning. So link 1 and link 2, they form one turning pair. Next, link 2 and 3, they form the second turning pair. After this we have link 3 and here link 4, they are forming one sliding pair, and link 4 and link 1, they are forming the second sliding pair. So we have two sliding pairs and two turning pairs. So this is an example of double slider, or you can say double slider crank chain, This is the Scotch yoke mechanism. Next, another example of double slider crank chain is an elliptical trammel. I'll draw the diagram for that. So we have another example of double slider crank chain. Another example is an elliptical trammel, which is used to draw ellipse. Now, in case of elliptical trammel, here also it is double slider crank mechanism, in which we have two sliding pair and we have two turning pair. As we can see in this diagram, when we say that link 2, it is the crank because motion would be provided to link 2. Now, here we are fixing link number 4. Previously, in case of Scotch yoke mechanism for double slider crank chain, we had fixed link 1. Now, if link number 4 is fixed and link 1 is the first slider, link 3 is the second slider, link 2 is the connecting rod. So when we are giving rotation to link number 2, in that case, the motion which we are giving to the link 2, because of that, the path is generated and the sliding motion of both the sliders, it would be constantly changing and we are getting the motion as an ellipse. So here elliptical trammel is used to trace an ellipse, and we can see that the two of the pairs, they are sliding and two are turning pair. So this is an example of double slider crank chain. I hope you all have understood this.